Hello, everybody. Thank you very much for joining us today for our talk, Event-Driven to Data-Driven. In today's talk, we are going to explore how we transform observability at Vodafone. My name is David Yambor, Head of Systems Engineering at Vodafone.
Hi, and I'm Vishal Vaskar. I'm a Cloud Solutions Architect at MMT Digital.
Thank you very much for you guys joining us today. Before we start talking about observability, I would like to explain why we are talking about that. A bit more than a year ago, Vodafone made a big decision to transform from a traditional telecommunication company to a new 21st century technology company. And this is a big undertake which needs to happen in order to achieve that. So we have been asked the question, how are we proposing to make this change? So our answer was DevOps. We want to make sure that we are using and leveraging DevOps best practices from automation till monitoring, and we want to make sure that we are introduce this culture to the entire business if we truly want to transform into a technology company. So we got the answer quite quickly. How? DevOps. But what does it exactly mean? What do we want to achieve exactly? So we knew that our target is the customer experience. The customer is in our heart of everything which we are doing. So we need to make sure that we are improving the customer experience for the better if we want to show value of why are we doing it. So we know how to do it. Let's just define what kind of KPIs, what kind of targets do we need to achieve to call ourselves successful. So what we said is if we want to improve customer experience, we want to improve time to production so that the development teams can react quicker, more release can happen, therefore more features can come live in a much frequent manner. So we said we want to improve drastically by 90% of our lead time to production. Now, in order to achieve that, we also wanted to make sure that we are improving reaction time, because it's great that we are getting into production quicker, but if any unexpected things happen, we want to make sure that we are reacting much quicker. So the ambitious 90% has been set there as well. Now, cost effectiveness is something which is really important for us. So what we said is we want to make sure that we are achieving 40% greater cost awareness than what we've been before, and we want to reduce our cost to do the same. Now, we wanted to also make sure that 50% less bugs are reaching production at any given time, and 75% improvements we would like to see on the security side of things as well. These are really ambitious goals, but they are nicely contributing to improve our customer experience and call ourselves a meaningful, successful transformation. So in order to achieve all of this, though, we said about DevOps. DevOps is a certain set of principles, and this brings the culture piece, which is really important. We want to make sure that everything which we are doing are empowering this culture and highlighting the need and explaining why this is super important. So we discussed why are we doing it, how are we planning to do it, and what do we want to do exactly. So before I hand over to Vish, who can explain what we did in the last 6 to 12 months to actually achieve certain things out of this already, I want to make sure that we are defining what actually observability is. Observability means many different things for many different people. For some of you, it may mean logs, metrics, correlations, and all the trace IDs. But for others, it probably means something on the line of dashboards, KPIs, alerting, callouts, on-call. So the overarching goal of all of these different thought processes always remains the same. Bring better visibility into the system. And if you can, combine business view with real-time data. And this is exactly what we did. We said we are going to start refining our observability so that we can understand how are we doing today, and we can define the KPIs of how and where do we want to move in the future. I'm now handing it over to Vish, who can explain what we did in the last 12 months. Vish, over to you.
So thank you, David. Today I'm going to be talking about observability and how we do it at Vodafone. So just like every other business, a couple of years back, as our digital initiative, we started breaking down our monolithic services down into microservices. And as a part of that journey, we had three main challenges. The first challenge was that we started getting very thinly spread monitoring. The more microservices that we started building, the more monitoring that we got, the more databases that we had. We had very limited visibility to low-level components. So if there are any databases or any Redis clusters that we need access to, we wouldn't have direct access to them, and we'd have to go through channels to understand how we are performing. And the third and the most important point was that there was no easy access to observability for our engineers who are actually developing the applications. And that was critical for us. So a year back, just over a year back, we started our journey on getting SRE into the business. So we wanted to build an SRE culture. And as a part of that, we decided, okay, at this point, we don't have visibility. So let's start with an MVP approach. And the main thing that we wanted to do is every microservice should have performance visibility metrics readily available to all the engineers who are actually building it. As simple as that. So once we can get that, we can then get the engineers motivated to start understanding their own services and how they perform in production. But we can also use their help to try and build intelligent alerts rather than just having 70%, 90% CPU and memory utilization alerts, for an example. And then on our SRE journey, what we wanted to do is we wanted to hand over service ownership to the engineering teams themselves and then eventually auto remediate. So at that point, we came across the concept of observability as code. So ThoughtWorks captured this as a trial technique on their tech radar a couple of years back. And we really liked this technique. It was basically what we wanted to do within our business. Observability is a very key metric within our business to understand how we are actually doing on a day-to-day basis. So we decided, okay, let's come up with our own version of observability as code and our own definition of it. So what did it actually mean to us? Observability as code is a technique used for provisioning, configuring, and maintaining components such as monitoring, logging, alerting, and synthetics as code. And that is what observability as code, or what I will refer to as OAC throughout the presentation, means to us. Now, we now have OAC, and we want to get this integrated within the engineering teams. And how do we do it? So we started off with a simple standard. So according to Google SRE, dashboards, as an example, should answer basic questions about your service, and normally includes some form of 4 golden signals. For those of you who have read the Google SRE book, you all know what these golden 4 signals are. For those of you who don't know, it's latency, traffic, error, and saturation. Based on these 4 principles, we decided to go ahead with what is now called the RED standard, which is request, error, and duration. So we decided, why not we give basic Terraform templates to the developers within their own repositories, which would basically give them graphs with request, error, duration. And we did exactly that. So we had independent OAC, or observability as code, standards per microservice repository. We injected it into every microservice repository. And then we gave engineers full ownership, control, and access to make these changes on their own whenever they liked. And we gave them a basic standard, which means they had the red charts. But now if an engineering team A wants a Kinesis stream on their dashboards, they could simply go into their own repository, change the monitoring template, and then submit a PR, which would then be reviewed by one of our SRE engineers and then deployed using CI/CD. And then towards the night, it would again get auto-deployed just to make sure that our OAC standards and our observability is idempotent and immutable. So that leads us to incident management, and we call it incident management power level 10K. And the reason for that is, now that we have given every engineering team the OAC power, we can now get them involved in incident management and get them to understand how their microservices perform in an outage, or like what happens when there's an outage on their microservice. So we built this basic model where we had AWS, where all of our microservices were. we spooled out everything into Datadog, and within Datadog, we had OAC, using which we built dashboards, alerts, monitors, synthetics tests. And then whenever there were alerts triggered, they would then automatically get triggered within PagerDuty as an incident. A couple of months back, our engineers spoke about immutable telemetry at the PagerDuty Summit and how they do it using Terraform. We wanted to integrate our efforts into what they have done. And we did exactly that. So we integrated with them, got our OAC standards, and integrated technical business services into the same place. And it worked. And we reduced the gap between our mean time to discover and mean time to recover, because now we had everything in a single pane of glass. Everyone was singing from the same hymn sheet, and it was great. But whenever the story is too good, there's always a challenge, right? So initially, we started off, as I spoke earlier, OAC for dashboards, alerts, PD technical services, and then injecting them into developer repositories. Once we inject them in the developer repositories, they can use it, it gets built, and great, teams get called out. But that soon scaled out because every team wanted to get onboarded. So we onboarded every team, but what does that look like in an enterprise? That means we have loads of teams, and every team now had a technical service within PagerDuty, which would call them out, and had dashboards and alerts, and there was loads of stuff going on at the same time. And the challenge out there was that although we started calling out engineers, we started getting challenging situations where engineering teams started saying, well, hold on, I'm getting called out 10 times a day, but out of those 10 times, maybe 9 times, it's not because of our own service, it's because of a dependent service from whom we expect a response, which is down. And we don't know who owns that service. So we're going to hand this over to operations now and let them carry on. And we're going to resolve our incident. But basically, that was not the point. The point was that we have a very capable operations engineering team and a systems engineering team, and we wanted to integrate. We wanted to brew a culture saying this is all as one. We own the service. We build it, we ship it, we own it, as they say, right? So we understood this challenge, and we took it on as a head-on challenge thing. Okay, that is a legitimate problem. We have hundreds of microservices, and every microservice doesn't know who owns the other. So that led us to another challenge, which we basically came across. So we use Azure DevOps as our SDLC and general tool of choice for development. And we have all of our users, teams, and service ownerships mapped within Azure DevOps. And this is managed by our Scrum Masters, our product owners, and it's maintained, and it's well maintained because we have many teams developing at the same time. So, and we use Slack as our communication channel. So we decided, now that we know that Slack as well as Azure DevOps have really rich APIs at our disposal, why don't we build a Lambda function that actually uses both of these APIs and then gives the developers a single / command or some sort of an integration that would easily help them identify those relations that black box can then be opened. And we did exactly that. We basically gave them a / command, which would then talk to Azure DevOps, and then it would get some information out, and based on a service name, developers could now look at what version is deployed within which environment. And if there was an outage, whether the outage is because of a recent deployment, they could also check stack trace events, where they would get all CloudFormation updates within the same / command. And if it is not either of the two, then they could also get who is responsible for that service, show the team members, and directly get in touch with those team members. And this was a significant victory. Like it was really good for us because the developers now not only built their own microservices and used OAC, but they could also get in touch with dependent microservice teams without having to depend on someone to tell them, okay, you need to get onto a boiler with X, Y, and Z. They could just start these conversations and update their technical services on their own. So what that gave us is we had microservice performance visibility, and we gave everyone a baseline and gave them the freedom to build whatever they wanted. We still had our own dashboards, our own alerts, and top-level metrics, but now we had granular metrics of every microservice in their own form. So whatever the developers feel is the most relevant way. We had it in their own, like from their own eyes. We built intelligent alerts because now we started understanding trends for every microservice. And then based on those trends, we started saying, okay, it looks like at 2 o'clock on a normal day, we start getting peaks on a certain microservice. So we should scale that out. And then we started handing service ownership over after we knew that we could now give them full visibility of who owns what. And the engineering team were brave enough to basically say, yeah, okay, now that we can contact people on our own and we don't have an unknown, we are happy to take the services on board and work in collaboration with operations and the systems engineering teams. And that's where we are today. And it has been a huge success because it's just been over a year where we started this journey and we have already reached so far. And our next goal is to auto remediate, because now that we have learned how our microservices perform, we can now auto remediate our any outages. And that's what our engineers are working towards. So that was a little story about how we basically transformed some observability standards within our part of our business. And that nicely leads me into the next part, which is log-to-metric and behavioral analysis. So we, as Vodafone, are power users of Datadog. And we basically make use of every new feature coming in, and our engineers are on top of it. And what does that mean to us? And the reason why I mentioned log-to-metrics, because it's something that was released last year in Datadog Summit, and we make best use of it today within our business. So what does that mean? We have something called as platinum events, and they are the Black Fridays, the Cyber Mondays, the iPhone, Samsung launches. And these are very critical events for our telecom industry like us. And we take them really seriously. We have an entire operations team, an analytics team, and all of our teams basically engaged during these events. But the challenge is that the metrics that we were getting of how we performed on this event were basically getting to us at the end of the day. And although that's good, and we have those numbers, because now we have OAC, we thought, why not convert that into real time? Let's try to get the data source and then see whether we can have real-time metrics using the log-to-metric feature. So we use a simple 3-step approach. We identify the data sources, saying, okay, there are some critical order details which don't have any PII information, which basically we are allowed to use, and that's going into a database. Okay, let's ship that into Datadog using a Lambda, and then let's use a parser, and then use our OAC repository to build dashboards and visualizations for everyone. And when I say everyone, it's not only the engineering teams, I mean everyone. So on the left, this is what it would generally look like. This is what it looked like when we initially got a line of log from a database into Datadog and then parsed it into nice JSON. But then when we used log-to-metric, it gave us meaningful data, as you can see in the dashboard on the right. And these dashboards, we decided, why not display it across the office? So basically we have screens across our offices, and we display these dashboards to everyone across the office, whether it's a product owner, whether it's a C-level, or whether it's an engineer. Anyone could see these dashboards in near real time. And that was game changing, because now we were not only engaging engineers, we were also engaging C-levels and senior product owners, and product owners coming to us and telling us, oh, it looks like these baskets are failing. Are they failing because of genuine customer issues? Or are they failing because of an underlying microservice being down? Can you quickly please check? Or someone else coming in saying, oh, we did really great yesterday. The dashboards are green. And that was really good, right? It helped us in our initiative of moving the thought process of the entire business, not only our engineers, the entire business, towards a DevOps culture, towards an SRE culture, and towards a you own it, you ship it culture. So that has been really, really good so far. And we are going to continue this journey to build more and more innovative features within our, and innovative things that help our business think about observability in today's world as well. So this is where we are today. And at this point, I'm going to hand it back to David to talk about our future vision. Thank you, guys.
Thank you very much, Vish. This was a great overview. So just to remind ourselves, we wanted to build a culture, an SRE culture. And which overview nicely explained how we managed to achieve exactly just that. In short, we need to get to a common ground between devs and operation teams. So we built everything as code. Once we reached the healthy level of automation which we required, and which is easy to use by all members, we started to focus on empowerment and empowered our people to use them when they need it, but only when they need it. And this is what transpires to be an ownership at the end. So during our journey, we identified certain principles which we decided that we must follow if we want to continue building high quality, consistent systems. So the principles are easily reproducible systems, immutable, disposable, consistent, repeatable, and version control. Now, applying these principles are great, but when you start talking about choice of tool and what systems are you going to use in order to meet these requirements, we also created a wish list for any tool or any object which we decide to apply during our journey. And the requirements there are declarative orchestrations, declarative resource definitions, idempotency, secret management within the environment as code, tag-based convention on any cloud system, and everything must be able to packaged in a container so that's easily shippable and testable. So this is what we learned, but what we actually achieved. Using these principles, we improved our MTTA, which is mean time to acknowledged, by 80%, improved our MTTR, which is mean time to resolve, by 50%, but more impressively than that, we have built over 500 dashboards automatically out of the box to the business owners. Using these techniques, even if our development teams are shipping a new service which other part of the business not fully understand or aware, this enables us to automatically create the necessary dashboards, KPIs, alerting, call-out rules, and everything around that out of the box. And this is the real power. So where are we going next from here? What do we want to achieve further? We want to put heavy focus on development teams to be in the center of every tool and automation which we are doing. We want to make sure that the devs are in control over their code. Because we are talking about shared ownership and ownership from top to bottom, meaning from development teams to production, we want to make sure that the development teams can make the decisions which is needed for a high quality service, but they can also understand the journey and capable of taking responsibility of any event happening between the dev cycle until it reaches production, and capable of supporting any event happening in live production at any moment needed. So in order to achieve all of this, we are going to put heavy focus on self-serving capabilities. We want to make sure that all of our teams are capable of requesting on-demand new environments, new tooling. They can decide what type of test and when they want to run on demand. And we want to make sure that this is done in a self-serving manner. So there is no bottleneck, no wait time, and that's hopefully going to drive the lead time to prod much lower than where we are right now. In order to achieve all of this, we want to make sure that we are still capable of governing and empowering certain standardization practices. And therefore, we are putting heavy resources into our CI/CD pipeline, improving our quality gates, and making sure that we are capable of enforcing certain high-level standards, which gives a really clean indication to the dev teams that what is important for the business and what are the objects where they have freedom of choice and what are the things which has been decided for them. So that was our presentation. Thank you very much for listening in. We are going to switch over for the Q&A. Thank you very much.